One morning, you wake up, check your phone, and see something impossible. All the ice on Earth is gone. Every glacier, every ice sheet, every snowflake just vanished. The world you knew has completely changed overnight. So what would this new Earth actually look like? And more importantly, could this nightmare ever become real? Let me take you on a journey through a world without ice. We'll explore which places would disappear, where people could survive, and who's already planning to profit from our melting planet. Earth without ice. Here's something that might surprise you. An ice-free Earth isn't actually that unusual. We've been there before. Right now, we're living in what scientists call an interglacial period. That's a fancy way of saying we're technically still in an ice age, just a warmer part of it. For the past 12,000 years, things have been relatively stable, but go back 130,000 years, and Earth was even hotter than today. Temperatures were 2 degrees above what they were before factories and cars started pumping out pollution. Sea levels stood 6 to 9 meters higher than right now. But go even further back. 100 million years ago, if you stood in Antarctica, you wouldn't see a single snowflake. Instead, you'd be standing in a thick, subtropical forest. Picture the forests of New Zealand, but in the most unlikely place on Earth. During summer, the sun never set. For 6 months, there was constant daylight. Then came 6 months of total darkness, and somehow life thrived. Dinosaurs walked through these Antarctic forests, giant armored ankylosauruses as long as a small bus stomped around. Massive, long-necked sauropods grazed on plants. This was normal. This was Earth without ice. Back then, sea levels were 200 meters higher than today. That's the highest they've been in the last 540 million years. It's taller than a 60-story building. Today, things look very different. Antarctica is covered by an ice sheet bigger than the United States and Mexico combined. At its thickest point, the ice goes down almost 5 kilometers. That's deeper than most of the ocean. This single ice sheet holds 60% of all the fresh water on our entire planet. Greenland chips in another 8 to 10%. The rest comes from mountain glaciers, smaller ice caps, and something called the cryosphere. That includes sea ice, snow cover, and vast areas of frozen ground called permafrost. Altogether, there are more than 5 million cubic miles of ice on Earth. If every bit of it melted, we'd be in serious trouble. Sea level rise. Let's talk about what happens when all that ice melts. The number you need to remember is 70 meters. That's how much global sea levels would rise. To put that in perspective, that's about shoulder height with the Statue of Liberty. Most of that water comes from Antarctica. If just the Antarctic ice sheet melted, sea levels would jump 58 meters. Add in everything else and you hit that 70-meter mark. The world map would get a brutal redesign. Let's start with the United States. On the west coast, Los Angeles would be completely underwater. San Francisco's famous hills would become a cluster of islands poking out of the ocean. The Central Valley, where much of America's food is grown, would become a giant bay. The East Coast would face an even worse fate. The entire Atlantic seaboard would vanish beneath the waves. Florida would be gone, not partially flooded, completely gone. New York City, underwater. Washington, D.C., the nation's capital, would cease to exist. Boston, Miami, gone. Europe wouldn't fare any better. The Netherlands, a country that has fought the sea for centuries, would lose that battle forever. All of it, underwater. Denmark would be mostly gone. Nearly half of Belgium would disappear. London, where Big Ben and Buckingham Palace stand, would be submerged. The United Kingdom would break apart into a scattered archipelago of islands. Paris would flood. Venice, already sinking, would be reclaimed by the sea completely. In Eastern Europe, something strange would happen. The Black Sea and the Caspian Sea would connect for the first time in 5.5 million years. Countries like Kazakhstan or Uzbekistan and Turkmenistan would finally have direct access to the ocean. Of course, by then, they'd have bigger problems to worry about. Asia would be devastated. Beijing, Shanghai, Seoul, Tokyo, all underwater. The entire country of Bangladesh, home to 173 million people, would vanish beneath the waves. Can you imagine that? An entire nation gone. 600 million Chinese people would lose their homes. Much of coastal India would flood. The Mekong Delta would disappear, turning Cambodia's mountains into islands. South America would see massive changes too. The Amazon basin in the north and the Paraguay River basin in the south would become extensions of the Atlantic Ocean. Buenos Aires, one of South America's largest cities, would be wiped out. Coastal Uruguay would be gone. Most of Paraguay would flood. Africa would actually lose less land compared to other continents, but that doesn't mean they'd escape the horror. Cairo and Alexandria in Egypt would be casualties. Parts of the west coast would flood. Lagos would disappear. And here's the thing about Africa. Even if the land doesn't flood, the rising heat would make much of it impossible to live in. Australia, mostly desert, would gain a new inland sea, but it would lose the narrow coastal strip where 4 out of every 4 Australians currently live. Add it all up, and you're looking at 40% of the world's population, over 3 billion people losing their homes. Not damaged homes, gone, completely underwater. Earth's rotation. Losing billions of homes is horrifying, but there's something even more dramatic that would happen. The planet itself would change the way it moves. Think about an ice skater spinning. When they pull their arms in close to their body, they spin faster. When they extend their arms out, they slow down. Earth works the same way. Right now, most of the ice sits at the poles, close to the axis of rotation. When all that ice melts, the water spreads out across the oceans, away from the axis. This makes Earth spin slower.
But how much slower? Scientists calculated that if just Greenland's ice melted, each day would get 2 milliseconds longer. Greenland holds about 1/10 of all land ice, so if all the ice melted, days could get several milliseconds longer. That might not sound like much, but it's comparable to how much the moon slows Earth down over an entire century. And for our modern technology, it would be chaos. GPS systems need precise timing to work. Satellites orbit at exact speeds. Flights follow carefully calculated routes. Space missions depend on split-second accuracy. All of that would be thrown into complete disarray. The planet would also start to wobble differently. This wobble, called polar motion, would shift Earth's spin axis. The imaginary line connecting the North and South poles would move. That shift would trigger changes to our climate, seasons, and weather patterns. Northern areas might see longer, hotter summers. Southern regions could face harsher winters. Ocean currents like the Gulf Stream, which keeps Europe warm, could veer off course. The jet stream could shift, creating storms in places that never saw them before. Droughts could last years in some regions. There's something else. Right now, the weight of Antarctica's ice pushes down on the continent below. Take away that weight, and the land would slowly bounce back up. Scientists call this glacial isostatic adjustment. Think of it like pressing down on a memory foam mattress. When you stand up, the mattress slowly returns to its original shape. In Scandinavia, this is already happening. The ice from the last ice age melted thousands of years ago, but the land is still rising. In Sweden, an ancient port called Osthammar became landlocked by 1491. The whole town had to move. In some places, the land rises 1.4 centimeters every year. If all of Antarctica's ice melted, this rebound would happen on an enormous scale. The land would reshape itself over thousands of years, and that would cause local sea levels to keep changing long after the ice was gone. The instant all that ice melted, Earth's gravitational field would change too. Antarctica's massive ice sheet is so heavy, it actually pulls ocean water toward it. When the ice disappears, that pull vanishes. This could make sea levels rise even more in tropical regions near the equator. A 70-meter sea level rise could become even worse for people living in those areas. What lies beneath the ice? So what's actually under all that ice? For the past century, scientists have been mapping the ground beneath Antarctica using satellites, radar, and gravity measurements. What they found is remarkable. Antarctica isn't flat under all that ice. It's full of sharp mountains and deep valleys. In fact, Antarctica has the deepest land canyon on Earth. It plunges 3.5 kilometers below sea level. That's deeper than the Grand Canyon is tall. The canyon is also 100 kilometers longer than the Grand Canyon. The continent is split into 2 distinct parts. East Antarctica is generally higher and sits on stable bedrock. West Antarctica is actually a collection of mountainous islands. Scientists have also discovered 675 lakes hiding beneath the ice. The largest is called Lake Vostok. It's 250 kilometers long and sits 4 kilometers under the ice. Lake Vostok has been isolated from the rest of the world for 15 million years. The creatures living in it have been evolving separately all that time. Who knows what they'd do if they were suddenly exposed to our world? Antarctica also has hundreds of volcanoes. In West Antarctica alone, scientists have identified 138 of them. Greenland's underside is less explored, but scientists know it has mountains and at least 60 smaller lakes beneath the ice. There's something else under the ice, something that might be dangerous. Ancient microbes and viruses have been trapped in the ice for thousands, maybe millions of years. If all that ice melted, these ancient organisms would be released into the world. Our immune systems have never seen them before. We'd have no natural defense. Some of these ancient bacteria are linked to diseases like cystic fibrosis. But here's what's really scary. These bacteria are resistant to the antibiotics we use today. If they mix their genes with modern bacteria, that resistance can spread. We'd lose our ability to fight off infections. One biotechnology company called GelTech is working on solutions for tough infections like these. Their gel-based system can deliver higher doses of medicine with controlled timing. It's designed for cases where regular pills aren't strong enough. The technology helps nearly 1 billion people worldwide who struggle to swallow pills. But technology alone won't save us if ancient diseases are unleashed. The microbes aren't all bad, though. Scientists think some could help us create new, better antibiotics. Others might help clean up toxic waste or even create biodegradable alternatives to plastic. Under the ice, there's also an entire hidden ocean. About 1.5 million square kilometers of ocean sits beneath Antarctica's ice. Scientists have sent robots down to explore it. They found something unexpected. Anemones, small creatures that usually stick to one spot like plants, were living on the underside of the ice. But these Antarctic anemones were wriggling around in the water, moving from place to place. There were also small fish and crustaceans. But here's what's really weird. These creatures were eating ancient matter that's been frozen for millions of years. Old skeletons, bodies, and bacteria from when Earth was much warmer. It's like they're eating rotting food that's been in the back of a fridge for millions of years. The fight for the Arctic. An ice-free Antarctica and Greenland wouldn't just be empty wastelands. They'd be full of valuable resources. Deep beneath the ice, there are rare minerals, coal and oil. Right now, mining in Antarctica is banned under an international treaty, but in a world where all the ice had melted, would those treaties still exist? Based on human history, probably not. Greenland alone has 25 of the 34 minerals that the European Union considers critical. That makes it the 8th largest known reserve in the world. This is one reason President Donald Trump has tried to buy Greenland more than once. We're already seeing a fight for Arctic resources today, even with the ice still there. The Arctic Circle sits between North America and Europe, Asia. It's a powerful location for military bases. It's also full of natural resources. The U.S. Geological Survey estimates the Arctic has 48 billion cubic meters of natural gas and other fuels. That's equal to all of Russia's oil reserves. It's 3 times more than what the United States has. China calls the Arctic their Polar Silk Road. They want the trade routes and resources. But here's the thing. China has no Arctic border. Their northernmost major city is at the same latitude as Venice, Italy. Still, they call themselves a near-Arctic state. In 2024, the last piece of privately owned land, the Arctic archipelago of Svalbard, was put up for sale. The price was $324 million. People called it the gates to the Arctic. The Norwegian government had to step in and cancel the sale to prevent China from buying it. This wasn't the first time either. China has tried to buy seaports in Norway and Sweden, and even an airport in Greenland. Every time, they've been blocked. Russia and the United States are also competing for Arctic territory. As the ice melts, nations are rushing to claim whatever they can. Some people are already profiting from the melting ice in creative ways. Off the coast of Svalbard, an entrepreneur named Jamal Qureshi literally picks up blocks of Norwegian glacier ice from the ocean and bottles it. Each bottle sells for $100. Production is limited to 13,000 bottles per year because the ice is so hard to collect. In the Yakutia region of Russia, melting permafrost is revealing 11,000-year-old mammoth remains. In China, there's massive demand for this ethical ivory. A single mammoth tusk can sell for up to $100,000 on the black market. The people who collect these remains are called tuskers. They carry powerful water pumps on their backs and carve out enormous tunnels, sometimes 180 feet long, under the frozen ground to extract the bones. The race for Arctic resources is very much on. If Antarctica and Greenland became ice-free, we'd likely see the same scramble there. Could it really happen? So here's the big question. Could all the ice actually melt? The short answer is no, not in our lifetimes, not even in the next several hundred years. The longer answer is more complicated. Total melt is very, very unlikely, but we could get close, maybe too close. We know significant ice loss has happened before. 130,000 years ago, during the last interglacial period, sea levels were 6 to 9 meters higher than today. That means large parts of Greenland and West Antarctica must have melted. Temperatures back then were 2 degrees above pre-industrial levels. Today, we're already at 1.1 degrees higher, and we're heading in the wrong direction. Human activities, mainly burning fossil fuels, are driving temperatures up. If emissions continue at the current rate, the Intergovernmental Panel on Climate Change predicts temperatures could rise between 3.3 and 5.7 degrees by 2100. Here's where it gets worrying. If we sustain warming of just 2 to 3 degrees, we could lose almost all of the Greenland and West Antarctic ice sheets. That would cause at least 13 meters of sea level rise. Some research suggests complete melting could happen by the year 3000. That's only 1,000 years away. In the timescale of climate and geology, 1,000 years is incredibly fast. In human history, it's unprecedented. We've had a relatively stable climate for the past 12,000 years. That stability is ending. What about East Antarctica, the massive ice sheet that holds most of Earth's ice? Scientists think it hasn't been ice-free in 66 million years, but under rapid warming, there are big uncertainties. Warm ocean water can melt the bottom of ice shelves, which makes glaciers slide faster into the sea. At the same time, when ice melts, the land beneath it rises, which can actually stabilize the ice. Scientists don't yet know which effect is stronger. These gaps in knowledge are driving a lot of current research. One glacier has scientists especially worried. It's called the Thwaites Glacier, but it has a much scarier nickname, the Doomsday Glacier. Thwaites is massive, about 120 kilometers wide. That's roughly the size of Florida. It's melting incredibly fast. Every year, it sheds 50 billion tons of ice into the ocean. So far, it's responsible for 4% of the sea level rise that's already happened. Some scientists think the whole thing might collapse in decades, not centuries. If it does, sea levels would rise by 65 centimeters, about 2 feet. That might not sound like much, but Thwaites acts like a cork in a bottle. If it collapses, it could trigger a chain reaction, causing other nearby glaciers to collapse too. The entire West Antarctic ice sheet could follow. That would add about 4 meters to sea levels. Scientists won't know for sure what's going to happen until 2100 or later. There's another factor we haven't talked about much: permafrost. Permafrost is ground that's been frozen at the poles for over 40,000 years. As it thaws, it releases carbon dioxide and methane that have been trapped all that time. These gases cause more warming, which melts more permafrost. It's a feedback loop. Think of it like putting a frozen dinner in a microwave. As the permafrost thaws, tiny organisms wake up and start eating the ancient organic matter. As they do, they release CO2 and methane. The planet gets hotter. There are other feedback loops too. Ice reflects sunlight, keeping Earth cool. Ice reflects 50 to 70% of the sun's light, but ocean water, being dark, only reflects 6%. As ice melts and exposes more ocean, more heat gets absorbed. That melts even more ice. Warmer water also means more microscopic fungi become active. These fungi decompose dead matter in the ocean, releasing carbon dioxide. More warmth means more decomposition, which means more CO2. Fresh water from melting ice also creates a layer on top of salty ocean water. This makes the ocean less efficient at absorbing CO2 from the air, which adds to warming. All of these small processes work together. Each bit of melting leads to more dramatic consequences. Scientists are still working to understand exactly how all these pieces fit together.
The ocean conveyor belt. When ice melts, it doesn't just raise sea levels, it disrupts the entire ocean. The world's oceans move heat around the planet through a system that works like a giant conveyor belt. Dense, salty water sinks to the ocean floor. This pushes less dense water up to the surface. The movement transports heat and nutrients from one part of the world to another. It takes about 2,000 years for water to complete one full trip around the globe. This system is critical for marine life. Nutrients from the ocean floor feed tiny organisms called phytoplankton. They might be microscopic, but they're the foundation of the ocean food chain. Without them, most ocean life would collapse. When massive amounts of fresh water from melting ice pour into the ocean, the system gets disrupted. Fresh water is less dense than salty water, so it doesn't sink as far. The conveyor belt jams up. Heat stops moving properly. Nutrients stop reaching the surface. Scientists have been studying how Arctic melting affects the Gulf Stream, which keeps Europe warm. They're still figuring out how Antarctic melting would change global climate. Under some conditions, if icebergs broke off from Antarctica and melted far away in the Atlantic, the changes could actually trigger an ice age. But if the melting mainly raised sea levels, we'd probably just get a much hotter Earth. Not all phytoplankton would suffer equally. Around Antarctica, the melting ice would actually provide iron and nutrients that were trapped in the ice. This could cause a temporary massive algae bloom. Those algae would absorb some carbon dioxide, which is good, but it wouldn't be nearly enough to offset all the other warming. The bottom line is this: if Earth warmed enough to melt all the ice, average temperatures would be 5 to 10 degrees Celsius warmer than now. That's 9 to 18 degrees Fahrenheit. The average temperature on Earth would be around 27 degrees Celsius or 80 Fahrenheit. The tropics would become too hot for humans to survive. People would be forced to move toward the poles. Canada, Alaska, and the newly exposed Arctic and Antarctic regions would become the new tropical paradises. 34 million years ago, Antarctica was a temperate rainforest. Maybe it would be again, with palm trees on the coast and warm oceans full of life. But to get there, billions of people would have to die first. The human cost. Let's be clear about what we're talking about. If all the ice melted rapidly, most people living on coastlines would drown. 3 billion people live near coasts. In a sudden melt scenario, the vast majority wouldn't escape. People in tall buildings might race to the rooftops. Those on the 23rd floor or higher might have a chance. But there wouldn't be enough helicopters or boats to rescue everyone. Governments would be in complete panic, trying to organize emergency operations while their own capitals were flooding. Anyone smart enough to jump in their car and drive inland as soon as the water started rising might survive, but only if they could reach higher ground. Only a lucky few would make it. Even the survivors would face a nightmare. Salt water would flood farmland, destroying crops. Underground aquifers that provide drinking water would become contaminated with salt and bacteria from the melted ice. Suddenly, there would be a severe shortage of fresh water. With farms destroyed and water contaminated, food would become scarce. Heat stress would make it impossible to work outside in many regions. At 4 degrees of warming, labor capacity could drop by 30 to 50% in the hottest areas. The World Bank estimates that climate change could drive 120 million people into extreme poverty by 2030, even without complete ice melt. With all the ice gone, that number would be far higher. Disease would spread. Ancient bacteria resistant to modern antibiotics would mix with our drinking water. Infectious diseases like dengue and malaria would expand into new areas. The World Health Organization calls climate change one of the biggest threats to global health in the 21st century. With complete ice melt, it would be the biggest threat, period. Some scientists estimate 14.5 million additional deaths by 2050 from climate change on our current path. If emissions continue rising through the end of the century, over 9 million people could die from climate-related causes every year by 2100. Those numbers are based on gradual warming. A complete ice melt would be far worse. Heat alone would kill millions. Right now, 30% of the global population lives in areas where extreme heat and humidity cause excess deaths. By 2100, that could rise to 50 to 75% of all people. In a completely ice-free world, it would be even worse. The tropics would become uninhabitable. Areas where 1/3 of humanity currently lives could become as hot and dry as the Sahara Desert. People would have no choice but to move toward the poles. This mass migration would create unprecedented conflict. Countries would struggle with millions or billions of refugees. Resources would become scarce. Competition for food, water, and livable land would be fierce. Marginalized communities would suffer the most. People with fewer resources have less ability to adapt or move. Indigenous peoples who depend on their land and ecosystems would lose everything. Women who face discriminatory norms and have less control over resources would be especially vulnerable. The economic damage would be catastrophic. Coastal cities hold most of the world's economic activity. New York, London, Tokyo, Shanghai, all gone. The global economy would collapse. What we can do? Here's the good news. We can stop this. The key is reducing greenhouse gas emissions as quickly as possible. We already know how to do it. We can phase out fossil fuels by stopping subsidies for oil, coal, and natural gas. We can switch to clean energy like wind, solar, hydro, and nuclear power. We can use that clean electricity to power cars, heat buildings, and run factories. We can also remove carbon from the atmosphere by planting more forests and changing farming methods to store carbon in the soil. In 2015, nearly every country in the world signed the Paris Agreement. They agreed to keep warming well below 2 degrees Celsius. But with current pledges, we're still on track for about 2.8 degrees of warming by the end of the century. That's not good enough. There's widespread support for climate action around the world. Most countries have committed to stop emitting CO2. The challenge is moving fast enough. Scientists estimate there's about a 50% chance we'll exceed 1.5 degrees of warming between 2024 and 2028. The 20-year average will likely pass 1.5 degrees in the early 2030s. We're running out of time to avoid the worst impacts. But total ice melt would take centuries or millennia to happen, even in a worst-case scenario. We still have time to prevent it. The question is whether we have the will.
The reality we face. Yes, complete ice melt is unlikely in our lifetimes, but significant ice loss is not. The Thwaites Glacier could collapse within decades. The West Antarctic ice sheet could follow within this century. That alone would displace hundreds of millions of people. We're already seeing the effects. 2024 was the warmest year on record, 1.6 degrees Celsius above pre-industrial levels. Arctic sea ice is disappearing. Glaciers are retreating faster than predicted. Sea levels are rising. And while this is happening, some people are already preparing to profit. Countries are competing for newly accessible Arctic resources. Entrepreneurs are bottling glacier water. Hunters are pulling mammoth tusks from thawing permafrost. The world is changing whether we like it or not. The question isn't whether we'll see impacts from ice melt. We're already seeing them. The question is how much worse we'll let it get. We still have time to act. We can keep this nightmare scenario hypothetical, but that window is closing. Countries would vanish. Continents would be reshaped. Cities would be destroyed, billions would suffer. The planet itself would wobble differently as it spins through space. This is the future we're creating if we don't change course. This is what's at stake. The ice is melting. The only question left is how fast.